Students, we are now going into the third video. We are going to rule number two. Rule number two, and I read and explain. Rule number two says, that is rule number two of solving problem associated with partial fractions. Factorize, if possible, the denominator into its prime factors. This is important since the factors obtained determine the form of the partial fractions. Example. So let's apply this rule. So what am I saying here? Given an algebraic function, before you resolve that function into partial fraction, you have to take a look at the denominator. If the denominator is not in factored form, you have to factorize it first. That is, if it is factorizable. That is what this rule is saying. That is, factorize if possible. That is, if that denominator is factorizable, factorize it first. Factorize if possible the denominator into its prime factors. This is important since the factors obtained determine the form of the partial fractions. Example number 2. We are now going to consider an example that is relevant to this very rule number 2. Example 2. Resolve 2x plus 5 over 2x plus 5 over x squared plus 3x plus 2 into partial fractions. In line with this rule number 2, you can see here that the denominator is a quadratic factor. Then you find out if it can be factorized. If it can be factorized, you have to factorize it first. So, solution. Solution. 2x plus 5 over x squared plus 3x plus 2 is equivalent to 2x plus 5 over x squared plus x squared plus x plus 2x plus 2. So the turn over. That's page 4. Turn over. So this means that 2x plus 5 over, said it's x squared plus x plus 2x plus 2. This is equals to, I'm seeing the process of factorizing the denominator. 2x plus 5 over x into x plus 1 plus 2 into x plus 1. So that is equals to 2x plus 5 over x plus 1 into x plus 2. Now, I factorize the given denominator into its linear factors, x plus 1 into x plus 2. So I am now in the process of resolving it into partial fractions. Say let 2x plus 5 over x plus 1 into x plus 2 be equivalent to a over x plus 1 plus b over x plus 2. Again, we clear the fraction as we did in the first example. I think by now you know how to clear the fraction. Clearing the fraction, we have 2x plus 5 is equivalent to a into x plus 2 plus b into x plus 1. Now, put x equals minus 1 in equation. Call this equation 1 for reference. Put x equals minus 1 in equation 1. Why are we doing that? So as to be able to eliminate b, to be able to eliminate constant b. So if I put x equals minus 1 in equation 1, my left-hand side will give me 2 into minus 1 plus 5 is equals to a into minus 1 plus 2 plus b into minus 1 plus 1. Minus 1 plus 1 will give you 0. 0 times b is 0. So I'm left with 2 times minus 1 is minus 2 plus 5 is equals to minus 1 plus 2 is 1. That will be a into 1 plus b into 0. So I have 3 is equals to a, or a equals 3. So the value of a is known. Now I have to find the constant b. In order to find constant b, I must choose value of x that will eliminate this constant a. So put x equals minus 2 in equation 1. So if I do that, the left-hand side of equation 1 will be 2 into minus 2 plus 5 is equals to a into minus 2 plus 2 plus b into minus 2 plus 1. Minus 2 plus 2 will be 0. 0 times a is 0. This is minus 4 plus 5 is equals to a into 0 plus b into minus 1. Therefore, 1 is equals to minus b, or b equals minus 1. So the values of a and b are known. I can now write my partial fraction. Therefore, 2x plus 5 over x squared plus 3x plus 2 is equivalent to a. And what is my a? My a is 3. 3 over x plus 1 minus 1 over x plus 2. This is my answer. This is my final answer. This is my final answer.